Welcome to another A-Level Computer Science Masterclass. This week we're going to be looking at network addressing, protocols, and also subnets. So in this particular lesson, we are going to start off by looking at the difference between our IP and our MAC addresses. We're also going to bring in the theory behind the TCP IP stack for actually sending our data within our networks. And we're also going to look at subnets and subnet masking. Now, ultimately, the whole reason for us having all of these addresses so that we can identify the various different devices on our networks, it's all about so that we can take our data packets from one machine to another. Ultimately, any form of network is two or more devices connected together to share data and other devices. So if we couldn't send our data between them, there's no point. So if you haven't already covered this in your GCSE, consider a data packet a little bit like a parcel. We've got lots of information that we want to be sending back and forth between our devices, and we can't always send that at the same time. So what we do is we break up our data into individual packets. Now you can see here, I'm going to break this up into 3 data packets. That's not technically true. It's probably going to be more like tens or hundreds. This one is going to have something in the header that says 1 of 3, 2 of 3, and 3 of 3. Now the reason for doing this is because quite likely we're going to be sending them all off in different directions. As they are sent, they're probably going to take the shortest path to the next computer. That doesn't necessarily mean that they're going to arrive in order, so the receiving computer needs to be able to identify all the packets and put them back together. The other thing we're going to want to be putting in those packets is where to. So each one of these gets a little to address and also a from. So very much like any other form of physical packet. This just happens to be a packet of data. Now you might also take those packets and encrypt them. Think about some of your encryption methods where you are using public private keys. Each one of these data packets is then going to be encrypted using the public and the private keys before it gets sent. So that's creating essentially like a little extra packet protection there, asking somebody to wear a jacket before they leave the house. So each one of these data packets is going to be created, packaged up, ready to send, and that uses a particular process. And once it reaches the other end, it then also needs to go through a particular door. So one of the things that you have to do when you form a data packet is to perform the creation of a thing called a socket. Now the socket is the IP address, and then linked to that is the port. So essentially it is the address and then the door to use. And not every single one of those doors is going to be open. The doors that we use in order to get through to our network are called ports. Imagine we have a boat. Here's our boat, and our boat is carrying cargo, and it's going to dock in port. It is the entry point to the rest of the network. So if you dock at your port, then all of your little data packets are going to be offloaded and put through to the network. Now the nice thing about ports is it actually links with our firewall. So let's make a little note here. Our firewall is where we are able to lock those doors or keep them open. So this allows us to provide additional security. So if somebody tries to get through on a port that's closed, they are simply going to be denied access. So at this point, imagine here we've got 4 of our possible ports into our network. Imagine them like closed doors. Now each one of them is going to have a number. So we've got port 25, we've got port 42, port 80 and port 91. And our firewall is going to identify whether they are locked or unlocked for particular network traffic. So in our case, port 25 and port 91, they are locked, which means any kind of traffic trying to get through using those ports, because of their socket. So remember, the socket is your IP address on this side, so this is the whole of our network, and then the port. So it's saying I want to go to this address, which is our network, using this door. So in this case, we have an email and it's going to try and get through on port 25. And because port 25 is locked, it's just going to be destroyed. The firewall is going to take this and get rid of it. The next email that comes through, now that uses a socket which has our correct IP, but it's going to use port 42. Now that particular door happens to be unlocked, which means that it's going to end up going into the network and it's going to be accepted. So the firewall in this case is doing its job using both the IP and the port. Now the next thing we want to be aware of is the fact that these data packets have to go through the TCP IP stack. Now, TCP IP, these are two separate protocols which have been combined together to show how we send and receive data. Now, you as an A-level student, you will need to know the TCP IP stack. It's very, very easy for you to look for network layers and end up with the OSI model. Now, the OSI model uses a very, very similar thing, especially with layers, but it has a lot more, it's in a lot more detail, and it's not something that we use. So if you are searching and you find the OSI model, don't do it. Go for the TCP IP stack. They are two different things. They also use slightly different layer names as well, so you want to be really careful. Now, the whole point of this is that we have person A over here, and we have person B over here. Person A is going to send some data over to person B, and in order for it to go from their device all the way over for person B to be able to see it, they need to use the TCP IP stack. Now at this stage, what happens is you've got the application layer. Now the application layer is where you can actually take data and it looks correct to the human. Now if it's going from the human into the stack, it's going from the humanistic version into something which is more digital. So this is where you have things like HTML. You may have things like HTTP. This is being able to present things on screen to the human. Well, in our case, it's now taking things that were on screen and sending them in. So it's going to follow this path all the way down here. When it gets to the transport layer, we're starting to create data packets. We're dividing things up. We're working out how we're going to be sending them. We are identifying whether we're going to be sending them individually or all on one line, whether we're using packet switching or circuit switching. That is the two different versions of being able to send packets across a network. We're working out whether this is going to go through a hardwire, whether it's going to go through Wi-Fi, and essentially building those packets up. We also at this point want to know who we're sending it to. Then we are going to go to the internet layer. This is where you get your IP addresses. So the internet layer basically identifies, this is my IP address, this is the IP of the address of who I'm sending it to, and it bolts that onto the header of every packet. The data link layer then uses your MAC address. So it gives you an adapter. So remember, not every network is going to be using a router. And if you're not using a router, you need to use a switch. And a switch will use a MAC address. So you're going to send two to addresses and two from addresses. Now at this stage, we've created the packets, we've created the tos, the froms, and at this stage we're ready to go. We're ready to send it across the network. And the bit that is missing at the bottom, which you see in the OSI model, but not in this one, is the physical layer. And that's where your data is now sent along its physical transmission, whether that is through wires or whether it is through Wi-Fi or a combination, and it's going to end up at the network of the person who is now going to receive it, or in fact is going to end up at the network interface card. And then it has to travel all the way up and unpack every single one of those items of data until we reach the application layer again, where it is translated from a computer version into something which is readable and understandable by a human. So the most important bit to remember here makes it understandable. Each one of these layers is a way of organizing the protocols. So if we talk about protocols, this is a set of rules for data transmission. That is your standard definition. So I'm just going to pop that up there. So we have a set of rules for data transmission, which is what a protocol is, and the TCP IP stack is a way of organizing those protocols to show how data packets are created, sent, and received.